Hola amigos, let me ask you a simple question. Have you ever run this command on your system? kubectl apply -f deployment.yaml, and when you apply it, you can check the status of the pod using kubectl get pods, and boom, you have your application running. But have you ever stopped and wondered what actually happened between these two commands? Who reads the YAML? Who creates the pod? Who decide on which node the pod should run, and finally, who creates the container. Most Kubernetes tutorial teaches you how to deploy on Kubernetes, but in today's video, we'll understand how Kubernetes think. So without further ado, let's get back into the journey. Welcome back to K8s with Pravesh. In the last episode, we covered deployment, services, stateful set. If you haven't checked it out, link would be in the description. Since creating these resources is getting very easy thanks to AI tools, but understanding how these resources are working under the hood is what separates a Kubernetes user from a Kubernetes engineer. So in today's video, we're going to follow a single deployment from your laptop all the way to a container running inside the cluster. Everything starts here. You type in kubectl apply -f deployment.yaml. At this point, no pod exists, no containers are running. You simply provided a Kubernetes manifest telling your desired state. And who gets the request? API server. So think of API server as the front gate of your Kubernetes cluster. Every request goes through API servers, whether it's coming from etcd, control manager, kubelet, or anything. So API server, it first authenticate the request, it validate the YAML file that we have provided, and once everything looks good, it store the desired states. Now, you might wonder, where does Kubernetes store this state file? The answer is etcd, the brain of Kubernetes. If you have worked with GitOps before, you'll know Git is the single source of truth. Inside Kubernetes, etcd is that single source of truth. It stores the entire configuration of the cluster. And here's something interesting. Even now, Kubernetes hasn't created a single pod. It just stores the desired state. So, who does the actual work? Comes in controller manager. So, think of it as someone asking, is the desired state of the cluster matches with the current state? And if the answer is no, it will take action. In our case, it will notice a deployment. But instead of creating a deployment, it will create something called as ReplicaSet. Let me tell you another interesting fact. If we go inside a YAML file, you'll notice we never mentioned ReplicaSet. We just specify we need 3 replicas. But if you run kubectl get rs, you'll see a replica set. That's because Kubernetes created the replica set automatically. This replica set ensures that the desired amount of pods always exist. If one pod dies, another one will spin up. But right now, inside our journey, these pods are still homeless. Now, our pod exists, but they don't know on which worker node they'll work. Here comes the job of scheduler. So scheduler watches all the worker nodes. It will check metrics like CPU usage, memory, affinity, and many other scheduling units and choose the best worker node for it. So our pod will have a home, but the question arises, who will actually start it? Every worker node has something called kubelet. So think of it as a node manager for the worker node. It constantly watches the API server, and the moment it notices, hey, this pod belongs to me, it will start preparing the node. It will talk to the container runtime, which is container D in most of the cases, that will pull the container image. If not present, it will create the container and start the container. And finally, we have our application running. So the whole journey looks like kubectl. It will enter the cluster through API server. etcd stores the desired state. We'll have control manager, replica set. scheduler, and then we'll enter inside worker node. We'll have Kubelet that will talk to container runtime, and container runtime will create the pod. Quite a journey for a tiny command, right? And that's why exactly Kubernetes isn't magic. It's a collection of components, each with a single responsibility, working through a reconciliation process. And once you understand this workflow, troubleshooting Kubernetes will become easier because you'll know where to look when things went south. I hope this video helped you understand what happens when you run kubectl apply. In the next episode of K8s with Pravesh, we'll pick one of these subcomponent and explain that in detail. If you like this video, make sure to give it a big thumbs up, share it among your network, subscribe to the channel, and share this video with someone who's learning Kubernetes. Until then, this is Pravesh signing off. Adios, amigos.